Okay, once again, we'll start by recording our given information. Give us a bit of a game plan. How much time? So right away, we know what we're solving for. We're trying to find t. How much time does it take a car traveling south? Now that's going to be critical, so we have to deal with that direction. It's traveling south at 12 meters per second, and it's increasing its velocity to 26 meters per second south. And they tell you that its acceleration is 3.5 meters per second squared, also south. So since south is down on the compass rose, why don't we say south is negative, just to keep track. So we're saying his initial velocity, which is a vector, is negative 12 meters per second. Negative is going to represent south. My final velocity is negative 26 meters per second south. And my acceleration, the rate at which my velocity is changing, is also towards the south at negative 3.5 meters per second squared. And remember what that means. My velocity is changing by negative 3.5 meters per second every second. We're trying to find t. Now from the previous question, we came up with an equation that looks like this. My final velocity is simply my initial velocity plus acceleration times time. If you're wondering, that is simply this equation here. Acceleration is change in velocity over time, where we've solved for v final. Remember the top of this, when I see this little triangle, that means change in. The top of this can be written as v final minus v initial, and we've just done some algebra. We end up with this expression on the left that's in yellow. So let's go ahead and solve it now. We want to solve this for t. So to get t by itself, let's get rid of the v initial first. Subtract VO from both sides. So I get v final minus v initial equals VO plus AT minus VO, minus V initial. And on the right-hand side, I've got a positive V initial and a negative V initial, so they're gone. Now, also attached to the T is an acceleration. And since it's attached by multiplication, we're going to divide both sides by A to get T by itself. So my left-hand side looks like this, V final minus V initial. And my right-hand side was A times T, where A is a vector. Divide both sides by A, and I get my expression. The time is given by V final minus V initial all over acceleration. Now all we have to do is put in the numbers. Time equals V final, negative 26 meters per second, minus negative 12 meters per second, all over negative 3.5 meters per second squared. Now, when I'm subtracting a negative, this becomes positive. Negative 26 plus 12 is negative 14 meters per second, that's the top, divided by negative 3.5 meters per second squared. And at the end of the day, I'm left with a time of 4.0 seconds.